Dear CS 330 TAs and professors, my name is Harry Jiang, and I'm a one-person group working on K-pop music classification using black box meta learning. So for my project, the tasks are twofold. The first task is to classify artists for K-pop music, and the second task is to classify individual songs in K-pop music. And the models that I use for comparison is first a black box meta learning model with LSTM, similar with what we used in homework one. And a second model is a traditional supervised learning model with conv and recurrent layers, specifically designed for artist classification. So for my data collection and pre-processing, I used a Spotify web API to collect almost 2,000 tracks from 11 artists. And those songs are 30-second preview versions for each song track. And then I'll use the library called Librosa to convert the raw audio files into mouse-scaled spectrogram. It's something like this. So for each song track, we have the times sequence as the axis and the y sequence as the intensity of the frequencies at different frequencies. And those are the intensities that are perceived by the human ear. And we would label the tracks by artist or by song number, depending on the task. And then for experiment one, I did artist classification using the black box meta learning model. And this is similar to what we did in homework one with 2 layers of LSTM. And I would flatten the 2D mouse spectrogram into a 1D input. And I did a 3-way 2 samples per class meta learning formation using a learning rate of 0.001. And I trained for 25,000 iterations on a Tesla K80 GPU. For experiment one, I did artist classification using a traditional conv and recurrent network this time. And I would feed the MEL spectrogram directly into the 2D conv layers and then some GRU layers and some dance layer, and then produce the final output. For the last experiment, I did song classification using black box meta learning. And it's very similar to experiment one, except that we would relabel the data using the song track number. And then for each song track, I would split the 30-second track into 3 10-second segments and perform a 3-way 2 sample per class training using the first 2 segments as the support set and the last segment as the test set. And it would be the same training parameters as experiment one. So this is the result that I got. This is the test accuracy that different models perform on different tasks. As you can see, the black box meta learning performed fairly well, much better than being random for 3-way classification at 0.49. But it didn't do too well on song classification, which is barely performing at random. But the traditional supervised learning does perform much better, as we can expect, because it's specifically designed for artist classification. And the main takeaways, the first one is that the black box meta learning shows more potential for artist classification than song classification, possibly because there are more examples per artist, and then there are more common features that we can extract for each artist. And the second takeaway is that there are still plenty of rooms for improvement for the basic all-purpose LSTM black box meta learning model, because we didn't really introduce any fancy architecture. It's just a very simple 2-layer LSTM. So we're hoping that maybe if we can port some of the conv and recurrent layers into the black box meta learning model, it could perform much better for this meta learning task. And that's all for my final project presentation. Thank you so much.